Hello there! In this video, I'm going to show you something that I think is just super cool. Alright, now this isn't all my idea. Almost none of it's my idea, actually. I read it in a paper. So let's see the citation for the paper. The paper is a discovery by Helen Skala, College Mathematics Journal, March 1997, pages 128 and 129. Alright, so what we're going to do is we're going to look at this plot of exponential functions. This is a variety of exponential functions. This is a plot of things of the form a to the x, where in this case a is bigger than 1. Alright, and what I want to do is I'm going to find, I'm going to look at tangent lines that go through the origin that are tangent to these curves. And I'm going to mark on these curves where it looks like they're tangent. So let's start with the first one. So I have to go through the origin and find where it looks like it's tangent. Let's make sure I go through the origin. Looks like it's tangent. Looks like it's tangent. Looks like it's tangent right around here. All right. So I've made my first mark with my curve. Now with the second one, let's see. I'm going to go through the origin and see where the curve is tangent. It looks like it's right around there. All right. And now I'm going to go through the origin and see where this is tangent to the curve right around there. All right. Now I'm going to go through the origin and see where the line is tangent to the curve. Let's see, it looks like right around there. All right. I'm going to go through the origin and see where the line is tangent to the curve. It looks like maybe right around here. All right. And finally, I have one more curve left, so I'm going to go through the origin and see where it's tangent. It looks like maybe right around here. Okay. Well, this is interesting. I wonder where these points are. It kind of looks like they might be all on a horizontal line, but it's hard to say. But what are the y values for those points that I just plotted? So I need to find tangent lines for f of x equals a to the x that go through the origin. Well, if I need to find a line, I have to find a slope. So we're going to write f prime of x is equal to a to the x times natural log of a. We learned this this week, that this is what the derivative of a to the x is. Of course, if we look at our plot here, we're finding the tangent line at some x-coordinate that's unknown each time, right? We're finding the tangent line at some unknown x-coordinate. So we're going to be looking at f of b, and b is just some unknown constant. So this is going to be a to the b times natural log of a. Now if our tangent line goes through the origin, we're going to have L of x is equal to x times a to the b natural log of a. All right, so this is going to work. This will tell us, so these are lines that go through the origin with some slope. Okay, we have the tangent lines, but how do we get the y values? Well, if we look at this, we need our line to agree with the curve at the point of tangency. So that means that we need f of b to equal our line evaluated at b. So this means that a to the b had better equal b times a to the b times natural log of a. Well, wait a second. I can cancel this, and so I get 1 equals b times natural log of a, which means that 1 over natural log of a is equal to b. This means that for any a, whatever the a is that gives you this curve, the value that is below this point, the x-coordinate of this point, is going to be 1 over the natural log of a. What is this number? What is the y value? Well, the y value is f of 1 over natural log of a, which is equal to a to the 1 over natural log of a. And I don't know what this is. So I'm going to set it equal to some number c. I don't know. I'm just going to call it c. And then I'm going to do some work to figure out what this must be. So I have a to the 1 over natural log of a is equal to c. So maybe a good first step would be to take the log base a of both sides so I can get my hands on this exponent. So if I do that, I'll have 1 over natural log of a is equal to log base a of c. And here's where some log rules are really going to pay off. Check this out. This is equal to the natural log of c over the natural log of a. Aha! So now I can cancel here and here, and I get 1 is equal to natural log of c. This tells me that c is equal to the number e. E is equal to 2.718281828459045, and so on. Wow! What a discovery! Since our work was not really dependent on the value of a, except for the fact that in this case a was greater than 1, we have that all these points are all on the same horizontal line, and that line is at height e. Isn't that cool? I mean, who thought that when you drew these tangent lines that go through the origin, that you would have this horizontal line appear out of nowhere, and its y-coordinate would be e. That's cool. All right, let's go do some more math.